Gold fever, a timeless tale. The year is 1848. A whisper travels on the wind. Gold. The California gold rush begins. Thousands flock west. They dream of striking it rich. They seek adventure and opportunity. The gold rush transformed America. It fueled industry and innovation. It reshaped the landscape and the nation. This timeless tale of ambition and discovery continues to inspire. The allure of untapped riches, the thrill of exploration. Today a new gold rush beckons. This time the frontier is not of land but of space. Space. The next frontier of fortune. Fast forward to the year 2080, humanity looks to the stars. Not just with wonder, but with purpose. The next gold rush is upon us. Space mining. Asteroids, planets, and moons hold unimaginable wealth. These celestial bodies are laden with precious resources. Gold, platinum, titanium, and more. These materials are essential for our technological advancement. Imagine a future where resources are plentiful, where energy is abundant. Space mining holds the key to unlocking this future. It's a future ripe with opportunity, a future waiting to be claimed. Asteroids, floating treasure chests. Asteroids are more than just chunks of rock hurtling through space. They are ancient relics, remnants from the early days of our solar system drifting silently through the cosmos. They are cosmic time capsules, preserving the history of our solar system in their rocky and metallic bodies. These celestial bodies hold invaluable clues to the formation and evolution of our solar system. By studying them, scientists can unlock secrets about the birth of planets and the processes that shaped our cosmic neighborhood. But asteroids are not just scientific curiosities. They are treasure chests filled with resources that could revolutionize our future. Some asteroids are incredibly rich in precious metals, far more than what we find on Earth. Gold, platinum, and rare earth elements are abundant in these space rocks. These metals are essential for modern technology, from smartphones to advanced medical equipment. The materials extracted from asteroids are used in electronics, medicine, and industry, driving innovation and progress in countless fields. Beyond metals, some asteroids contain vast amounts of water ice, a resource that is just as valuable. This water can be broken down into hydrogen and oxygen through electrolysis, providing essential elements for life support and fuel. Hydrogen and oxygen are crucial for rocket fuel and life support systems, making space travel more sustainable and efficient. Imagine a future where spacecraft can be refueled in space, reducing the need to carry heavy fuel loads from Earth. This would significantly lower the cost and complexity of space missions, opening up new possibilities for exploration and colonization. Asteroids hold the key to unlocking the solar system. By harnessing their resources, we can pave the way for a new era of space exploration, where humanity can venture further and achieve more than ever before. Pioneers of the final frontier. The dream of space mining is already becoming a reality. Companies like Planetary Resources and Deep Space Industries are leading the charge. They are developing innovative technologies for asteroid prospecting and mining. Robotic spacecraft will be our eyes and hands in space. They will identify resource-rich asteroids. They will extract and process the materials. These companies are investing in the future. They are pushing the boundaries of human ingenuity. Their work will pave the way for a new era of space exploration and resource utilization. Section 5. The technological tightrope. In the vast expanse of space, humanity stands on the brink of a new frontier. The dream of space mining, once a figment of science fiction, is now becoming a tangible reality. But this dream comes with its own set of formidable challenges. Space mining presents immense technological challenges. The vast distances, the unknown variables, and the sheer scale of operations required are daunting. We are not just talking about sending a few astronauts to the moon. We are envisioning entire fleets of spacecraft dedicated to mining operations. We need to develop advanced spacecraft and equipment. These machines must be more than just functional. They need to be highly efficient, reliable, and capable of operating autonomously for extended periods. Engineers and scientists are working tirelessly to design spacecraft that can handle the rigors of space mining. These must withstand the harsh conditions of space. The environment in space is unforgiving. Spacecraft and equipment must endure extreme temperatures, from the blistering heat of direct sunlight to the freezing cold of shadowed regions. They must also be resilient against space weather and the constant bombardment of space debris. Radiation, extreme temperatures, and micrometeoroids pose constant threats. Space radiation can damage both electronic systems and human health. Micrometeoroids, tiny particles traveling at high speeds, can puncture spacecraft and equipment, causing catastrophic failures. We need to develop efficient and safe extraction methods. Extracting valuable resources from asteroids and other celestial bodies requires precision and care. Robotic arms and automated systems must be designed to handle the delicate task of mining without causing unnecessary damage. We must minimize the environmental impact on these celestial bodies. Preserving the pristine nature of these environments is crucial. Unchecked mining activities could lead to irreversible damage, altering the landscape and potentially affecting future scientific research. But these challenges also present opportunities. The quest to overcome these obstacles is driving innovation at an unprecedented pace. Scientists and engineers are constantly brainstorming and testing new ideas, pushing the boundaries of what is possible. The need for innovative solutions will drive technological advancement. The challenges of space mining are forcing us to rethink traditional approaches and develop cutting-edge technologies. This drive for innovation is not just limited to space. It has far-reaching implications for various industries on Earth. We will develop new materials, propulsion systems, and robotics. The advancements made in these areas will revolutionize not only space exploration but also industries such as manufacturing, healthcare, and transportation. These technologies will have applications beyond space mining. The materials and systems developed for space mining will find uses in everyday life, improving efficiency, safety, and sustainability in numerous fields. They will benefit industries on Earth and further our exploration of the cosmos. The technological advancements driven by space mining will pave the way for future missions, enabling us to explore deeper into space and unlock the mysteries of the universe. The technological tightrope we walk today will lead us to a brighter, more advanced tomorrow. Section 6. A universe of economic opportunity. The economic potential of space mining is staggering. The resources harvested from asteroids could be worth trillions of dollars. This new industry will create countless jobs. Engineers, technicians, miners, and support staff will be in high demand. Space mining will also reduce our reliance on Earth's resources. It will alleviate environmental pressures on our planet. We can preserve Earth's resources for future generations. Imagine a future where energy is clean and abundant. Space mining can make this a reality. Section 7. Space Law, writing the rules for a new frontier. As we venture into this new frontier, we must address important legal and ethical questions. The vast expanse of space presents unique challenges and opportunities that humanity has never faced before. Who owns the resources in space? This question is not just about ownership, but also about the fair distribution of these resources. How do we prevent conflicts over these resources? The potential for disputes is high, given the immense value of space minerals and the strategic advantages they offer. The Outer Space Treaty of 1967 provides a framework. It was a groundbreaking agreement that established space as a global commons. It states that space is the province of all mankind. This principle is crucial as it emphasizes that space exploration and utilization should benefit all humanity. But it does not specifically address space mining. As technology advances, the need for clear regulations becomes more pressing. We need to develop international agreements and regulations. These agreements must be inclusive, taking into account the interests of all nations, big and small. These must ensure the responsible and sustainable development of space resources. Sustainability is key to preserving space for future generations. We must protect the space environment for future generations. This includes preventing space debris and ensuring that our activities do not harm the delicate balance of the space ecosystem. The collaboration of nations is essential. By working together, we can create a comprehensive legal framework that addresses the complexities of space exploration. Our actions today will shape the future of space exploration. It is our responsibility to ensure that this new frontier is governed by principles of fairness, sustainability, and cooperation. Writing the rules for this new frontier is not just a legal necessity, but a moral imperative. Together, we can pave the way for a future where space is a shared resource, benefiting all of humanity. Section 8. The future is up there. The future of humanity is inextricably linked to space. Space exploration and resource utilization are no longer the stuff of science fiction. They are the inevitable next steps in our evolution as a species. We have the opportunity to create a future of abundance and prosperity, a future where humanity is no longer bound by the limits of Earth, a future where we can explore the cosmos and unlock its secrets. Section 9. Join the final gold rush. The next gold rush is not for the faint of heart. It will require courage, ingenuity, and a pioneering spirit, but the rewards are immeasurable. So I ask you, will you join us on this incredible journey? Will you be a part of the next great chapter in human history? The future awaits in the stars. Let's reach for it together. Space has always beckoned humanity. It represents the ultimate frontier, a vast and mysterious realm waiting to be explored. But what if this final frontier held the key to solving some of Earth's most pressing problems? What if the riches of space could usher in a new era of prosperity and progress? The answer lies in the burgeoning field of space mining, a concept once relegated to science fiction, but now on the cusp of reality. For centuries, we have looked to the stars with wonder. We have charted constellations, landed on the moon, and sent probes to distant planets. Now, we stand at the precipice of a new era, one where we shift from mere exploration to active utilization of space resources. This shift promises to revolutionize not just our understanding of the cosmos, but also our very way of life here on Earth. Imagine a future where platinum group metals, rare on Earth but abundant in asteroids, fuel a new generation of clean energy technologies. Picture vast solar arrays in space, beaming clean and limitless power back to our planet. These are just glimpses of the transformative potential that space mining holds. The journey won't be easy. Technological hurdles abound and ethical and environmental considerations must be carefully addressed, yet the potential rewards are too great to ignore. As we stand on the brink of this new frontier, one thing is certain. Space mining has the power to reshape our world in profound and unimaginable ways. Among the celestial tapestry of our solar system, asteroids stand out as tantalizing targets for resource extraction. These remnants from the early solar system are cosmic time capsules, harboring vast quantities of valuable materials. Unlike Earth, where heavier elements have sunk to the core, asteroids offer these resources in relatively accessible forms. Consider platinum group metals, essential components in electronics, catalytic converters, and various industrial processes. Their rarity on Earth makes them incredibly valuable. Asteroids, however, contain these metals in far greater abundance. A single kilometer-wide asteroid could contain more platinum than has ever been mined on Earth. Water is another critical resource found abundantly in space. While seemingly mundane, water in space is a game changer. It can be broken down into hydrogen and oxygen, providing breathable air for astronauts and, crucially, rocket fuel. This transforms space travel, allowing us to refuel in space instead of relying solely on costly and inefficient launches from Earth. These are just a few examples of the wealth that lies within asteroids. From iron and nickel to rare Earth elements, the potential resources are staggering. Unlocking this cosmic bounty has the potential to revolutionize industries, address resource scarcity on Earth, and fuel humanity's expansion into the cosmos. Extracting resources from asteroids, millions of kilometers away, presents immense technological challenges. It requires innovation, ingenuity, and a bold vision for the future of space exploration. Fortunately, rapid advancements in robotics, spacecraft propulsion, and resource extraction techniques are paving the way for this ambitious endeavor. Robotic spacecraft will play a pivotal role in space mining. These autonomous explorers, equipped with advanced sensors and manipulation systems, will be our eyes and hands in the harsh environment of space. They will prospect for resources, extract valuable materials, and even begin the process of refining and processing them in situ. Transportation is another critical aspect. Efficiently moving mined resources from asteroids to Earth or other destinations in space requires innovative propulsion systems. Concepts like solar sails, ion engines, and nuclear thermal propulsion are being actively explored, promising faster and more cost-effective travel across the vast distances of space. As we venture further into the cosmos, the need to build and maintain infrastructure in space becomes paramount. 3D printing technology, utilizing materials found in space itself, could revolutionize space construction. Imagine building habitats, research stations, and even entire settlements using resources harvested from asteroids. Section 4. Space Law, writing the rules for a new frontier. The dawn of space mining presents a new set of challenges that extend beyond the realm of technology. As we reach for the stars and begin extracting resources from celestial bodies, we must grapple with fundamental questions of ownership, rights, and responsible use. A new era requires a new set of rules, the development of comprehensive and equitable space law. The 1967 Outer Space Treaty, a cornerstone of international space law, declares that space is the province of all mankind and prohibits national appropriation of celestial bodies. However, it remains unclear how this principle applies to the extraction and utilization of space resources. Does mining an asteroid constitute ownership? Who has the right to extract and profit from these resources? These are complex questions with no easy answers. International cooperation and dialogue are essential to establish clear legal frameworks that prevent conflicts and ensure the responsible and equitable development of space resources for the benefit of all humankind. Moreover, space law must address environmental concerns. Mining activities should not leave a trail of debris or cause undue harm to the space environment. Sustainable practices, including resource recycling and minimizing waste, will be paramount to preserving the pristine nature of space for future generations. Section 5. Earthly Impacts. Balancing prosperity and responsibility. The potential benefits of space mining for Earth are undeniable. It promises to alleviate resource scarcity, drive technological innovation, and create new industries and jobs. However, we must also carefully consider the potential economic and environmental impacts of bringing vast quantities of space resources back to Earth. The influx of resources from space could disrupt existing markets and industries. A sudden abundance of platinum group metals, for example, could impact prices and have ripple effects throughout the global economy. Managing this transition carefully will be crucial to minimize economic disruption and ensure a smooth integration of space resources into existing markets. Furthermore, we must consider the environmental impact of transporting materials from space to Earth. The re-entry of spacecraft carrying tons of resources could release greenhouse gases and other pollutants into the atmosphere. Developing sustainable transportation methods and mitigating potential environmental risks will be essential to ensure that space mining benefits Earth without compromising its delicate ecosystem. Section 7. Reaching for the stars. Space mining and the expansion of humanity. The allure of space exploration has always been deeply intertwined with the human desire to expand our horizons, to push the boundaries of what's possible, and to establish a presence beyond our home planet. Space mining has the potential to transform this dream into a reality, enabling the expansion of humanity into the cosmos and the establishment of a permanent human presence beyond Earth. The resources available on asteroids, such as water, metals, and building materials, can be utilized to construct habitats, research stations, and even entire settlements in space. This would reduce our reliance on Earth for resources, allowing us to build a self-sustaining presence in space and venture further into the cosmos. Imagine a future where humans live and work on the Moon, on Mars, and among the stars. Space mining provides the stepping stones to make this vision a reality, unlocking the resources and infrastructure needed to build a future where humanity is no longer confined to a single planet, but thrives as a multiplanetary species. Picture this. The year is 2090. The world has changed in ways we could only dream of. Cities float in the sky, vehicles glide effortlessly through the air, and humanity has set its sights on the stars. Mankind has ventured beyond Earth, not just to explore, but to mine. Our reach extends to the farthest corners of our solar system, where we seek out new frontiers and untapped resources. Asteroids, celestial bodies teeming with precious metals and resources, become our targets. These space rocks, once seen as mere obstacles, are now treasure troves of opportunity. This isn't science fiction, it's a potential reality, driven by necessity and fueled by innovation. The technology we once saw in movies is now at our fingertips, making space mining not just possible but inevitable. For centuries we've mined our planet to fuel our progress. From the coal mines of the Industrial Revolution to the silicon mines of the digital age, our history is written in the minerals we've unearthed. But Earth's resources are finite, and the demand for them is ever growing. As our population expands and our technological needs increase, the strain on our planet becomes more apparent. space mining offers a solution, a way to access the raw materials we need to sustain our technological advancement and ensure a prosperous future for humanity. Imagine a world where the scarcity of resources is a thing of the past. This is not just about finding more of the same. It's about discovering new materials that can revolutionize our technology and way of life. We're talking about materials like platinum and palladium, essential for green technology and electronics. These elements, rare on Earth, are abundant in space, waiting to be harvested. Imagine a future where clean energy is abundant, powered by resources harvested from the cosmos. A future where our technological dreams are no longer limited by the constraints of our planet, but are instead fueled by the boundless potential of the universe. Our planet is a treasure trove of resources, but it's a treasure chest we've been plundering for centuries. We're facing a crisis: dwindling resources, environmental degradation, and a growing population demanding more. Look around you. Every smartphone, every computer, every piece of technology relies on metals mined from Earth. As our technological demands increase, so does the strain on our planet. Space, in contrast, offers a practically limitless supply of resources. Asteroids, remnants from the early solar system, are packed with metals and minerals, untouched and ripe for the taking. Mining these celestial bodies could provide the resources we need to sustain our civilization without further burdening Earth. Our journey into space has always been driven by exploration and the pursuit of knowledge. From Sputnik's first orbit to the Apollo missions, each step has brought us closer to understanding our place in the cosmos. But our relationship with space is evolving. We're no longer just explorers, we're becoming prospectors, entrepreneurs, and miners. Space mining, once the realm of science fiction, is now a tangible possibility. Technological advancements are making this possible. Reusable rockets, advanced robotics, and innovative extraction techniques are bringing the dream of space mining closer to reality. The same spirit of innovation that took us to the moon will propel us towards this new frontier. The solar system is littered with asteroids, remnants of its tumultuous formation. These asteroids are more than just space rocks. They're cosmic treasure chests, brimming with valuable resources. Some asteroids are rich in metals like iron, nickel, and cobalt, essential for construction and manufacturing. Others contain platinum group metals, highly valued for their use in electronics, catalysts, and even cancer treatment. Then there are the C-type asteroids, rich in water ice and organic compounds. This water can be broken down into hydrogen and oxygen rocket fuel. Imagine refueling stations in space, supplied by asteroid mining, enabling us to travel further and explore more. Section 5. Asteroid Mining 101, From Prospect to Payload. The first step in asteroid mining is finding the right target. Space telescopes and robotic probes will be our scouts, identifying asteroids with the most valuable resources and assessing their accessibility. Once a suitable asteroid is identified, mining operations can begin. Robotic miners, controlled remotely from Earth, will land on the asteroid and begin extracting the desired materials. Different techniques will be used depending on the asteroid's composition and structure. Extracted materials can be processed in space, reducing transportation costs. Imagine building infrastructure in space, using resources mined in space, a truly sustainable approach to space exploration and resource utilization. Section 6. Space Economy, a new frontier of prosperity. Space mining has the potential to revolutionize our global economy, creating new industries and unimaginable wealth. The resources harvested from asteroids could fuel technological advancements, drive down costs, and usher in an era of unprecedented prosperity. Imagine a world where platinum, a key component in fuel cells and catalytic converters, is as abundant as aluminum. This could revolutionize the clean energy sector, making green technology accessible to all. Space mining also opens up opportunities beyond Earth. The resources we extract could be used to build infrastructure in space, from orbiting space stations to lunar bases, paving the way for humanity's expansion into the cosmos. Section 7. The Challenges of Space Mining, a bumpy ride ahead. Space mining is not without its challenges. The harsh environment of space, the vast distances involved, and the technical complexities of operating in a vacuum pose significant hurdles. Developing reliable and cost-effective launch systems is crucial. We need to be able to transport equipment and personnel to and from asteroids efficiently and safely. Radiation shielding and life support systems for human miners are also critical considerations. Then there are the legal and ethical questions. Who owns the resources in space? How do we ensure responsible mining practices that don't damage the space environment? These are complex issues that require careful consideration and international cooperation. Section 8. Safeguarding the cosmos, ethical and environmental concerns. As we venture into space to mine its resources, we must proceed with caution and responsibility. The allure of untapped resources is strong, but we must remember that our actions have far-reaching consequences. The vastness of space should not be mistaken for an open invitation to exploit it without regard for its delicate balance. Each celestial body, each asteroid, and each planet has its own unique environment that could be disrupted by careless mining activities. International agreements and regulations are crucial to prevent the overexploitation of celestial bodies and to ensure that space mining benefits all of humankind, not just a select few. These treaties must be robust and enforceable, with clear consequences for violations. We need to establish clear guidelines for resource extraction, waste management, and environmental protection. This includes developing new technologies that can minimize the environmental footprint of our activities in space. Sustainability should be at the forefront of our efforts. By investing in renewable energy sources and eco-friendly technologies, we can reduce our reliance on finite resources and ensure that our activities in space are sustainable in the long term. We must learn from our mistakes on Earth and strive to develop mining practices that minimize environmental impact and ensure the long-term health of our solar system. This means adopting a holistic approach that considers not just the immediate benefits of resource extraction, but also the long-term consequences for the environment and future generations. Engaging with scientists, ethicists, and the global community is essential to create a framework that balances economic interests with ethical and environmental considerations. Only through collaboration and shared responsibility can we hope to safeguard the cosmos for future generations. Section 9. Humanity's Future Among the Stars, a Universe of Possibilities. As we stand on the brink of a new era, the dream of living among the stars is no longer confined to the realm of science fiction. It is becoming a tangible reality, driven by our relentless pursuit of knowledge and innovation. Space mining is not just about extracting resources, it's about expanding our horizons, pushing the boundaries of human ingenuity, and securing a brighter future for generations to come. By tapping into the vast wealth of minerals and materials found in asteroids, we can fuel our technological advancements and create new industries that were once unimaginable. Imagine a future where humanity becomes a multiplanetary species, with settlements on the Moon, Mars, and beyond, all made possible by the resources we extract from asteroids. These celestial bodies hold the key to building sustainable habitats, providing the raw materials needed for construction, life support, and even agriculture in space. Imagine vast space stations, powered by clean energy from space, serving as hubs for scientific research, exploration, and even tourism. These stations could become the new frontier for human civilization, where scientists and explorers work hand in hand to unlock the mysteries of the universe and develop technologies that benefit all of humanity. This is the future that space mining could unlock. A future where humanity's reach extends beyond the confines of our planet, a future filled with endless possibilities. The resources harvested from asteroids could enable us to build spacecraft capable of traveling further than ever before, opening up new pathways to distant stars and galaxies. It's a future worth striving for, a future where we become guardians of not just one planet, but of our place in the cosmos. As we venture into the unknown, we carry with us the hopes and dreams of countless generations, united by a common goal: to explore, to discover, and to thrive among the stars. This is the promise of space mining, and it is a vision that inspires us to reach for that. Imagine a future where the wealthiest individuals aren't the creation of advanced materials. The benefits of space mining will permeate every aspect of our lives. The quest to mine asteroids will necessitate unprecedented levels of international cooperation, technological innovation, and human ingenuity, potentially ushering in an era of unparalleled progress and prosperity. As nations come together to tackle the challenges of space mining, we will see a new era of collaboration and unity. The shared goal of exploring and harnessing the resources of space will bring humanity closer together, fostering a spirit of cooperation and mutual benefit that transcends borders and differences. Space mining is no longer a concept confined to the realm of science fiction. What was once the stuff of imaginative novels and blockbuster movies is now becoming a tangible reality. The idea of extracting valuable resources from celestial bodies like asteroids, the moon, and even Mars is gaining traction, and the implications are profound. It's a rapidly developing field, driven by advancements in robotics, artificial intelligence, and space exploration technology. These technological leaps are enabling us to envision and execute missions that were previously thought impossible. The integration of AI with robotics allows for precise and efficient operations in the harsh and unpredictable environment of space. While still in its infancy, the industry is showing immense promise. Early-stage operations are already demonstrating the feasibility of these ambitious projects. Prototypes and pilot missions are laying the groundwork, testing the limits of our current technology, and providing invaluable data for future endeavors. Companies like Planetary Resources, once a trailblazer in the field, have paved the way for a new generation of startups eager to stake their claim in the cosmos. These pioneering companies have inspired a wave of innovation and investment, attracting the brightest minds and the boldest entrepreneurs to the field of space mining. These companies are developing innovative techniques to identify, capture, and process resources from asteroids. From sophisticated scanning technologies that can detect valuable minerals beneath the surface to advanced robotic systems capable of operating autonomously in space, the tools of the trade are evolving rapidly, laying the groundwork for a future where space mining becomes as commonplace as terrestrial mining is today. Imagine a world where the resources we need are no longer limited to what we can extract from our own planet. This shift could alleviate some of the environmental pressures caused by traditional mining and open up new economic opportunities. The potential of space mining extends far beyond just precious metals. While gold, platinum, and other valuable metals are certainly a draw, the true potential lies in the vast array of materials that can be harvested. Rare earth elements, which are critical for modern electronics and other industrial metals, could be sourced from space, reducing our dependence on terrestrial mining. Water, a vital resource for human survival and a key component in rocket fuel, can be found in abundance in the form of ice on asteroids and the moon. This discovery is a game changer. Water can be split into hydrogen and oxygen, providing both life support and fuel for spacecraft, making long-duration missions more viable. Extracting water in space could drastically reduce the cost of space travel, making it more feasible to establish permanent human settlements off-Earth. The ability to refuel spacecraft in space would eliminate the need to carry large amounts of fuel from Earth, significantly lowering launch costs and enabling more ambitious missions. This, in turn, would open up even more opportunities for resource extraction and further exploration of our solar system. Permanent settlements could serve as bases for mining operations, scientific research, and as stepping stones for missions to more distant destinations like Mars and beyond. The dawn of space mining marks not just a new chapter in human history, but the beginning of an entirely new volume. As we stand on the brink of this new era, the possibilities are as vast as the cosmos itself. The journey ahead is filled with challenges, but the rewards promise to be equally monumental, heralding a future where humanity truly becomes a spacefaring civilization. To truly grasp the transformative potential of space mining, one must understand the sheer scale of the resources locked away in celestial bodies. Take, for instance, the asteroid 16 Psyche. This metallic behemoth, located in the asteroid belt between Mars and Jupiter, is estimated to contain enough iron-nickel ore to satisfy Earth's industrial needs for millions of years. Its value? A staggering $10,000 quadrillion, a figure that dwarfs the entire GDP of our planet. Psyche is just one of countless asteroids estimated to hold trillions of dollars worth of valuable resources. These celestial treasure chests contain not only precious metals like gold and platinum, but also rare earth elements essential for modern electronics, clean energy technologies, and advanced medical treatments. The abundance of these resources in space could revolutionize industries on Earth, potentially alleviating resource scarcity, reducing environmental impact, and driving down the cost of essential technologies. Section 4. Pioneers of the Final Frontier. Several key players are leading the charge in this final frontier of resource extraction. Companies like Deep Space Industries, with their ambitious plans for asteroid prospecting and resource utilization, are developing the technologies that will make space mining a reality. Governments, too, are recognizing the strategic importance of securing a foothold in this burgeoning industry. NASA, through its Artemis program, aims to establish a sustainable presence on the moon, which could serve as a stepping stone for future asteroid mining operations. The involvement of these major players underscores the growing legitimacy and potential of space mining. Their investments, both financial and intellectual, are driving innovation at an unprecedented pace. As the technology matures and the economic viability of space mining becomes increasingly evident, we can expect to see even more players, from established aerospace giants to ambitious startups, joining the race to unlock the riches of the cosmos. Section 5. The Space Race 2.0. The race to mine asteroids is often compared to historical gold rushes, but the stakes are immeasurably higher. In the 19th century, we will unlock new opportunities, face unprecedented challenges, and redefine what it means to be explorers in the